Let us now go to the 15th sum. Capacitors P and Q have identical cross-sectional areas A and separation D. The space between the capacitors is filled with a dielectric constant epsilon r. Calculate the capacitance of the capacitors P and Q. Capacitors, spelling mistake. P and Q. So now we have two capacitors. Capacitor P and capacitor Q. They are filled with dielectric here. The area of both the capacitors is same. It's a parallel plate capacitor. There's a dielectric here. The permittivity of dielectric is epsilon r. Or dielectric constant is epsilon r. Now they say the distance or thickness of the capacitor is the dielectric is d. In this case also the dielectric thickness must be d here, but you just see it's half only. You come to the later. Now you see in the first case, the dielectric is only half of the area, doesn't fill the complete area. So now let's see each thing separately. Then we'll go to the second one. So first let's see the first one. What is the capacitance of A? I'll rub this thing, I'll rub the question also. So let's see the first one. For capacitor A, just see the area of the capacitor is A, but the dielectric is only A by 2. And now you see there is, in this case there's R here. This side there will be dielectric. So we have two capacitors now, two capacitors in parallel. So first we'll see this one. We'll see the formula here first. First we'll see the formula. So we know that for a parallel plate capacitor, C is equal to epsilon naught A by D. This for a parallel plate capacitor. Now you see there are two capacitors. So this is like having two capacitors. This capacitor can be redrawn like this way. Let's see now. This first R filled capacitor, first part, and then in the second part we have the dielectric filled capacitor. So second one has the dielectric, the first one is having R. R is the dielectric here. So there are two capacitors here. Let's use the formula. This is for R. So let's see the formula here. So we can mark this one as in C and C dash. This is a capacitor C and this capacitance will be C dash. So let's see now, this area will be A by 2 and this one's area is A by 2 because half of this now, so A by 2. So let's see for the total capacitance now. So in this case, if you see, the capacitance will be for the left one will be equal to, for C will be equal to, that will be equal to, so epsilon into A by 2. So why A by 2 is, instead of A I'm writing here A by 2. Divide by the distance D. And then for capacitance C dash. So let it be there itself. So we'll bring this 2 down. So C is equal to epsilon naught into A by 2D. We get this now. Then for C dash. So we have C dash is equal to epsilon naught into epsilon R will come. Into A by 2 divided by D. Bring this 2 down. So what we have is C dash is equal to epsilon naught into epsilon R into A by 2D. This is D here. Now we got these two values here. So what to do now? These are two capacitors in parallel. So the capacitors are in parallel. Let's write down. Parallel means what to do? Just add them. So Cp is equal to C plus C dash. Just add the capacitances. So I'll write these values here and then I'll rub this part. So C dash we got, that is epsilon naught into epsilon R into A by 2D we got. Let me rub this part here. Then we can add them. So we have here, that is Cp is equal to, we got C plus C dash. Okay, what is C epsilon naught into A by 2D plus this one is epsilon naught into epsilon R into this is A by again that is 2D. Okay. So now what is common here? You take common terms. Epsilon naught A and 2D common. So you write it like this way: epsilon naught into A by 2D. Okay. In the first one we have 1 plus the second one we have epsilon R. Okay. So this will be the value for the capacitance of P. Okay. So it's a very easy thing we got now. Okay. Now we'll go for the second capacitor. Let me rub this out. Now I have drawn this second capacitor, that is Q. Let us see how to find the capacitance. Okay, it's very simple only. Let's see this now. Okay. So in this case we see the area is A again. Okay, there's no problem area. But see the distance here. Okay, this is just D by 2 and this distance will be D by 2. That is total distance D we saw. Okay, so it's like having two capacitors now. Okay, one with a dielectric and a second one with that. Okay, so it's like how we can draw. Okay, let me write it like this. It's like two capacitors, okay, with dielectric R and the dielectric medium. Okay, of with medium R. With the mediums R, okay, and another medium, but it will be like in series now. Okay, let's see how it is. So this will be the first capacitor which has R inside. Okay, R is dielectric. Then the second capacitor is like this way. Actually all of them are same distance only. Area same. Okay. The second one has a dielectric here. Okay. You see now they are both in series now. Okay. So let's see how to find the total capacitance. Okay. Very simple. We must know. First we'll write for this one we write as say C. Okay. And this is C dash again. Okay. We'll find what is the capacitance here. So very simple. We know the formula for capacitance C. Okay. We know C is equal to epsilon naught into A by, but the distance you see becomes D by 2 now. Okay, the thickness that becomes D by 2, and this one's thickness also is D by 2. Okay, so here we have for this for R. Okay, for R as a dielectric, we have here D by 2. Okay, so now what happens? 2 will go up. Okay, so we have here C is equal to 2 into epsilon naught into A by D. Okay, this is clear. This is D, it's not clear. Okay, now it's clear. So this is for capacitance with dielectric R. Next we'll see capacitor with a dielectric, that is this one, second one, C dash. Okay, so let's see for the dielectric filled capacitor. Okay, for dielectric medium, let's see what happens now. In this case, C dash is equal to, again the formula, epsilon naught into epsilon R, you must write, that's relative permittivity, into A by the distance is again D by 2. Take this 2 up. Okay, so what you have is C dash is equal to 2 into epsilon naught, epsilon R into A by D. Okay, it's now just simple. Just see what happens is in this case, the two capacitors are in series. Okay. The capacitors are in series. So series means what formula you use? 1 by CS is equal to 1 by the C, first formula, first one, plus 1 by C dash. This formula you can use. Okay. So let's see now how to solve do this thing. So let me write here 1 by the C is value is what? 2 into epsilon naught into A by D. Okay, I'll write here plus 1 by this value 2 into epsilon naught into epsilon R into A divided by D. Okay, so what happens? This will go up now. D will go up. So what we get is d by 2 into epsilon naught a plus d by 2 into epsilon naught epsilon r into a. Now let me rub the left side. Excuse me. So rub the left side here. Okay, so let's see what we have now. So left side we have 1 by cs. Okay, then we'll have here what is common here. We'll take, or we'll take the LCM in the denominator. So first we'll take the denominator here. That will be 2 into epsilon naught epsilon r into a, and numerator we'll see in the first one epsilon r is not in the denominator. Okay, so you multiply by epsilon r. So epsilon r into d plus the second one we'll just write as it is, d. Okay, so let this way now. Now you can see what is common here. D is common. You can take d outside. Okay, so you have here 1 by cs is equal to d into epsilon r plus 1, okay, divided by 2 into epsilon naught into epsilon r into a. So now it's just very simple. Take reciprocal. Okay. Take reciprocal. So when take reciprocal, what happens? Cs is equal to, this will come up now. So 2 into epsilon naught epsilon r into a divided by d, okay, into epsilon r plus 1. Or you can also write 1 plus epsilon r also. Okay. So let me pause it for a moment. Now let me rub this part and then I'll write the final equation. Okay. Make it more clear, that's right. So we have here now cs is equal to 2 into epsilon naught into a by d. Okay. Now what happens is epsilon r is now, I'll take this side. So epsilon r divided by, in this case epsilon r plus 1. Okay. So what it is, I write in epsilon r terms this side, so it's more clear to understand. So this will be the value of the capacitance. Okay. It's so simple. Okay, just you need to go through the steps. Okay, write down clearly and then you can easily understand. So thank you for watching.